Peace and blessings to all. Thank you for joining our broadcast of this video. Please consider subscribing to Lost Tribe DNA and tapping on the bell for all notifications. This video is inspired by the post in the Semites and West Asian origins of Haplogroup TM184 by Hannibal across the Y Haplogroup T desk of Peter Landon, expedited by How Music Lost Tribe DNA. Here's a revised and formatted version of your paper titled Haplogroup J versus T, which is the better proxy for Shem? Haplogroup J versus T, which is the better proxy for Shem? Paper from ResearchGate titled Meanwhile in Megiddo, exploring the Araxian pedigree of Munye der Chadzan into the last glacial period via the patriarch Abraham and Zudzuana, the caveman, by Adam Cherson. Keywords: JM304, JM267, JP58, JZ18271, Phylogeography, Genography, Middle Eastern Studies, Semitic Studies, Biblical History. Despite Ira Gershwin's wise words, new evidence developed during a DNA-based family research project suggests that some assertions in the Bible may be truer than expected. Introduction. This paper closely examines the ancient genetics of one small lineage from a sub-branch of a people sometimes known as Semitic. The term Semitic has various meanings in current lexicons, primarily referencing a family of Afro-Asiatic languages, both modern and ancient. The ethnonym is used infrequently, but is still encountered. The term itself has biblical origins. Shemites are considered to be the descendants of Shem, one of Noah's 3 sons, the other 2 being Japheth and Ham. The Table of Nations in the book of Genesis depicts the entire human family as descended from Shem and his 2 brothers. Yet, as Ira Gershwin once reminded us, the things that you're liable to read in the Bible ain't necessarily so. New evidence developed in the course of a DNA-based family research project reveals facts about the Semites that suggest some biblical accounts may indeed have a basis in reality. Notably, at least 2 of the nations, defined biblically as stemming from Shem's son Arphaxad, the Arabic, Adnanite, and Hebraic, are confirmed by this study to have a shared Y DNA root, lending credence to that portion of the Arphaxad narrative. However, this analysis was flawed by the omission of haplogroup T-M70 and its subclades. Analysis of genetic findings in Megiddo and the role of haplogroups J and T. Recent genetic research on remains found in Megiddo has identified haplogroup J1 as a possible genetic marker for the biblical figure Ibrahim. In this context, J1 is often presented as the Semitic haplogroup, leading to both implicit and explicit connections with the descendants of Abraham, including the Israelites and Arabs. This study emphasizes haplogroup J1 as a key component of the population in Megiddo, a city of great historical and religious significance. However, the focus on J1 overlooks the presence of haplogroup T, which has also been found in Megiddo. This omission is problematic because haplogroup T historically had a significant presence in the Levant, as evidenced by remains discovered in various other locations. The lack of discussion about haplogroup T raises concerns regarding the completeness and objectivity of the research. If J1 is presented as Abraham's haplogroup, how can the coexistence of both J1 and T in the same geographical and historical context be satisfactorily explained without acknowledgement in the analysis? The situation is further complicated by findings in Abel-Beth Maaka, a site mentioned in the Bible that played an important role in the history of ancient Israel. Here, haplogroup T-CTS6280 was found, while haplogroup J1 was entirely absent. This indicates that haplogroup T constituted a significant part of the genetic composition of the Israelites. The disregard for this finding in studies emphasizing J1 suggests a potential bias in interpreting genetic data. As a royal city, the omission of Haplogroup T diminishes a comprehensive understanding of the genetic diversity of the Israelites. Other important sites in the Levant. Haplogroup T is found not only in Megiddo and Abel-Beth Maaka, but also at other key archaeological sites in the Levant, including Ain Ghazal, Jordan. The oldest remains of Haplogroup T in the Levant date to around 8,300 to 6,700 BCE during the pre-pottery Neolithic B period. Pekian Cave, Israel. In this cave, dating to the Chalcolithic period, 4,500 to 3,900 BCE, Haplogroup T was strongly represented, suggesting that this group may have originated from migrants from Anatolia and the Zagros Mountains. Alalak, Tel Achana, Turkey. During the Middle and Late Bronze Age, circa 2000 to 1200 BCE, Haplogroup T was present in this region, indicating a complex network of migration and trade. The overwhelming emphasis of Haplogroup J1, while totally disregard to T1A, as Abraham's haplogroup in studies of Megiddo and other Levantine sites, is incomplete and potentially misleading. The omission of Haplogroup T raises significant questions regarding the methodology and interpretation of genetic research in this context. A more inclusive approach that acknowledges the full genetic diversity would facilitate a deeper and more accurate understanding of population history in the Levant. Genetic analysis of southern Sham. During the Bronze and Iron Ages, results from Majido Hill and Apple Hill, Bet Maaka. The study analyzes ancient DNA samples from southern Sham, an area comprising Israel, Jordan, Lebanon, and present-day Palestine, which was known as Canaan in ancient times. This region played a vital role in cultural and genetic interactions among inhabitants during the Bronze Age, about 3,500 to 1150 BC, and the Iron Age, about 1150 to 586 BC. Genetic analysis included DNA samples of 93 individuals from 9 archaeological sites, including significant sites such as Apple Hill, Bet Maaka, and Tel Majido. These sites hold great historical importance and provide essential insights into the genetic composition of inhabitants during these critical periods. Apple Hill, located in northern Israel, plays an important role in the region due to its strategic location along major trade routes. A sample from an individual dating back to the Iron Age, circa 1011-846 BC, belongs to the Y DNA group TCTS 6280 and mtDNA group X2. This finding is crucial for understanding the genetic traits of the inhabitants of Apple Hill during the early Iron Age. Tel Majido, another significant archaeological site in northern Israel, was a major center during both the Bronze Age and the Iron Age. During the Bronze Age, Majido served as a Canaanite city-state, while in the Iron Age it became the administrative center of the ancient Kingdom of Israel. A sample from this site, dating back to the Bronze Age, around 1107 to 923 BC, belongs to the Y DNA group JZS241 and mtDNA group K1A. Genetic results. Genetic analysis has shown a significant degree of genetic continuity among various population groups inhabiting southern Sham during the Bronze Age and Iron Age. Despite cultural and geographical differences, various populations in the region exhibit strong genetic similarities. However, this continuity has also been influenced by migrations from the northeast, particularly from the Zagros and Caucasus regions, contributing to the genetic diversity in the area. The presence of haplogroups such as TCTS 6280 and JZS241 provides insights into the complexity of the genealogy of southern Sham residents and helps to understand patterns of migration and genetic mixing during these periods. Final conclusion. The genetic data from this study contributes to our understanding of the inhabitants of southern Sham during the Bronze Age and Iron Age. These findings provide valuable insights into genetic diversity and the impact of migration on population compositions in the region. They are essential for reconstructing the genetic history of these ancient civilizations. Thank you for watching, and please show your support by subscribing and liking and commenting on all of the videos on Lost Tribe DNA.